this section, let's see how to apply Thevenin's theorem in AC circuit. For that, let's consider two examples. So first example is this one. For the circuit shown below, obtain the current flowing through 10 ohm resistor using Thevenin's theorem. Here we are interested in the magnitude of current flowing through 10 ohm resistor. So we can use this sign at the moment which we are going to consider, plus minus and plus minus like this. Here two independent AC voltage sources are available, that is 50 angle 0 volt and 40 angle 45 degree. And as we can see here, we can have two inductive reactants having value J5 ohm each and one capacitive reactance having the value minus J4 ohm. So coming to the solution, what is the first step in Thevenin's theorem? First of all, we need to remove the 10 ohm resistor through which we need to find out the current. So first step is remove 10 ohm resistor from the circuit and mark the open circuit terminals as A and B. This is the corresponding equivalent circuit. Here we removed 10 ohm resistor from the circuit and marked the open circuit terminals as A and B. So second step is obtain open circuit voltage across A and B, that is nothing but Thevenin's equivalent voltage. So we know here the circuit is this part. So current flowing through J6 is 0. Current flowing through 2 ohm resistor is this loop current I. So as we are seeing from the terminals A and B, what is the open circuit voltage? In order to obtain open circuit voltage, we need to move from the point B to A and add all the voltage drops. As current in J6 ohm is 0, so this potential drop is 0. As current is flowing in this direction, the potential drop is like this. This is higher potential and this is at lower potential. So as we are moving from B to A and adding all voltage drops, so VTH is equal to voltage drop across J6 ohm plus voltage drop across 2 ohm resistor, that is rise in potential, that is we need to consider as plus 2 into I. Then this is fall in potential, that is minus 40 angle 45 degree volt. So as potential drop across J6 ohm is 0, that is 0. Then potential drop across 2 ohm resistor is 2 into I. Why it is taken as plus? It is rise in potential. Then it is negative, so minus 40 angle 45 degree. So in order to find out this potential between A and B, first of all we need to find current flowing through the circuit. So in this circuit, what is the current? Voltage divided by total impedance. So voltage is 50 angle 0 and total impedance is, here we can have J5, here we can have 2 and here we can have minus J4. Simplifying, we can obtain this answer. Calculator, we can have a mode selection. There we can select complex mode. Then 50 shift angle 0 divided by, what is the value? J4, that is 5I plus 2 minus 4I is equal to, so answer is coming 20. Again shift equal to minus 10. Clear? So in this way we can use calculator in order to find out the answer. So answer is coming as 20 minus J10 ampere. This form is known as rectangular form. We can convert this answer into polar form also. How to convert this answer into polar form? It is very simple by means of this calculator. You just put shift, then plus. Here we can have an option to convert rectangular form into polar form. And then just press equal to. So answer is coming as 22.36. Again shift equal to, you can obtain the angle as minus 26.56 degree. So after finding out I, we can find out 2 into I, that gives the voltage drop across 2 ohm resistor. So 2 into I is nothing but, when we are multiplying this with 2, we can obtain 40 minus J20. Then substituting in this equation, we can obtain VTH as 0. The potential drop across 6 ohm resistor is 0. Then 2 into I is obtained as 40 minus J20. Then that voltage source, here we can have a voltage source. So that we need to substitute. Let's see that one with the help of calculator. 40 minus 20I minus 40 angle 45. The result is coming as 11.7157. 11.7157. In order to obtain the imaginary part, again shift equal to, we can obtain the answer as minus J48.28. So this is in rectangular form. How to convert into polar form? You just press shift and plus and equal to, that gives the polar form. In polar form, the result is obtained as 49.69 angle. In order to obtain angle, again press shift equal to, you can obtain the answer as angle minus 76.36 degree. So in this way, you can use calculator in order to solve this type of problems. So second step over, we got VTH as 49.69 angle minus 76.36 degree, that much volt. Next step is to find out Thevenin's equivalent impedance. So in order to obtain Thevenin's equivalent impedance, we need to replace all independent voltage sources by short circuit. So in our examples, we can have two independent sources. Here we short circuited first voltage source. Here we again short circuited the second voltage source. So the remaining equivalent circuit is like this. Here we can see that these two reactants are coming in series. So net reactance is J5 minus J4, that is nothing but J1. So that net reactance J1 is in parallel with 2 ohm. That combination is in series with J5 ohm. So net impedance as seen from the open circuited terminal, that is nothing but Thevenin's equivalent impedance is equal to J5 plus J1 parallel with 2. Simplifying, we can obtain 2J divided by 2 plus J plus 5J. When we are entering those values in calculator, we can obtain the result as 0.4 plus J5.8. 0.4 plus J5.8. When we are converting that into polar form, the answer is obtained as 5.81 angle 86.05. So the Thevenin's equivalent impedance is obtained as 5.81 angle 86.05 ohm. So next step in this Thevenin's theorem is, we need to draw the equivalent circuit, Thevenin's equivalent circuit. This is the corresponding Thevenin's equivalent circuit. Any linear bilateral network with the output terminals A and B can be replaced by a voltage source VTH in series with an impedance ZTH. Here the value of voltage is obtained as 49.69 angle minus 76.36 volt and ZTH is obtained as 5.81 angle 86.05 ohm. Now next step is to find out the current flowing through 10 ohm resistor. So we need to reconnect the resistance which we removed in first step, that is 10 ohm is to be reconnected. So after reconnecting, we can use basic law in order to find out the current. So current flowing through the circuit is equal to voltage divided by total impedance. Here the voltage is VTH, total impedance is ZTH plus 10. Substituting, we can obtain the result as minus 1.115 minus J 4.02 ampere. When we are converting this answer into polar form, the result is obtained as 4.17 angle minus 105.50 ampere. Coming to the second problem, here we can have only one independent voltage source. Here we need to obtain the current through 10 ohm resistor. So first step in Thevenin's theorem is we need to remove 10 ohm resistor from the circuit and mark the open circuit terminals as A and B. So this is the corresponding equivalent circuit. Here we removed 10 ohm resistor from the circuit. So in this open circuited network, we need to find out the open circuit voltage, that is nothing but Thevenin's equivalent voltage. So in order to find out Thevenin's equivalent voltage, we need to move from B to A and add all voltage drop. You can use this path or this path. So the easiest path is this one. Therefore, let's consider this path. So in order to find out VTH, here the voltage drop in this path is 0. The voltage drop in this path is nothing but this impedance into I. It is rise in potential. Why? Because current is moving from higher potential to lower potential. As in 5 ohm resistor there is no current flowing, so the potential drop across this 5 ohm resistor is 0. That means VTH is nothing but the voltage drop across this impedance, that is capacitive reactance. So in order to find out that one, we need to find out this loop current, circuit current. What is current? Current is equal to voltage divided by the total impedance. Here voltage is 20 angle 30. Total impedance is 3 plus J10 minus J5. So current can be determined by means of this equation. 20 angle 30 divided by J 10 minus 5 plus 3. When we are solving this expression by means of calculator, you can obtain this answer. 2.998 minus J 1.665 ampere. When we are converting this rectangular form result into polar form, you can obtain the polar form result as 3.43 angle minus 29.036 ampere. What is VTH? VTH is equal to I into minus J5. Substituting the value of I as this one in this equation, we can obtain VTH as 17.15 angle minus 119.03 volt in polar form. So this is the result obtained in rectangular form. Next step in Thevenin's theorem is to find out Thevenin's equivalent impedance ZTH. It is the impedance seen through the open circuit terminal while making all independent sources to 0. Here we can have only one independent sources that we made to 0 by short circuiting. Then remaining circuit is looking like this. Here as we seen through the open circuited terminal, so this combination is in parallel with this impedance, which is in series with the 5 ohm. That is the Thevenin's equivalent impedance. When we are considering this path, the total impedance is 3 plus J10. That is in parallel with this capacitive reactance minus J5. That is in series with 5 ohm. So plus 5. So by using calculator, you can obtain the rectangular form result as 7.20 minus J 8.676 ohm. When we are converting that into polar form, the result for Thevenin's equivalent impedance is obtained as 11.28 angle minus 50.29 degree ohm. Now, next step in Thevenin's theorem is we need to draw the Thevenin's equivalent circuit. Any linear active bilateral network with output terminals A and B can be replaced by a voltage source VTH in series with an impedance. Here the value of voltage source is obtained as 17.15 angle minus 119.03 volt. And Thevenin's equivalent impedance is obtained as 11.28 angle minus 50.29, this much ohm. After drawing the Thevenin's equivalent circuit, we need to reconnect the resistance which we removed in first step. Now the current flowing through this circuit is I, which is nothing but current flowing through 10 ohm resistor. So I10 is equal to voltage divided by total impedance, that is ZTH plus 10. Substituting the value of VTH, ZTH in this equation, we can obtain the current flowing through this 10 ohm resistor as 0.8899 angle minus 92.27 ampere. In this way, we can apply Thevenin's theorem for solving AC circuit also.